All right. Yeah. So we are doing solving rational equations part 2. And so in part 1 we learned how to get rid of the denominators by multiplying by something that would cancel everything in the denominator. These are a little bit more interesting because instead of having monomials with one term on the bottom, sometimes you're going to have polynomials more than one term. And so to figure out what you want to multiply by, we're going to factor the denominators. I know that's shocking to everyone because we've been factoring everything. But if I were to rewrite this, and you could just put this underneath, I'm just going to make this neat. I'm going to factor this denominator. I'm going to take an x out of both terms and make it x times x minus 1. Okay, so just take an x out of both terms. X is a common factor. And now I can see that all of the denominators have an x, and this one also has an x minus 1. So what I need to make sure that I'm going to do is multiply this whole equation by x and x minus 1 to cancel that out. So just to make the notes nice and neat, I'm going to recopy this, but you might just want to write it next to what's up here if you're trying to save space. I'm going to take this whole thing. I'll use brackets instead of parentheses since I've got parentheses there. And I'm going to multiply it times x over x minus 1. And if you want to have a denominator, since these are fractions, it would just be 1. So we're not going to change these denominators. We're just going to try to get rid of them. Okay? And what it will look like to start with, we're going to distribute this out. So if I distribute it to this first term, I have a 4 on the top, and I'm adding on an x and an x minus 1. So I'm going to have 4x and x minus 1. The denominator is just being multiplied by 1, so it's just going to stay x. Okay? And I'm not going to distribute that yet. I might distribute something later, but we'll go through the canceling and then we'll distribute. Okay? So then I'm going to take it over here times the 3 over x. So I'm going to have 3x, x minus 1, and then x times 1 will just give me x. And then my last part of the equation will be right here. So I'm going to have 1 times x, x minus 1, so I can just make x, x minus 1. And then the denominator will also be x and x minus 1. So when we get done, if we've done this correctly, we will have gotten rid of all the denominators. So these x's cancel, and it leaves you with 4 times x minus 1. So is it okay if I go ahead and distribute that 4 in there? Are you guys cool with that?
Yeah.
Okay, so that's going to give me 4x minus 4. Then over here, these x's are going to cancel. Similar situation. I'm going to take 3 times x minus 1, so I'll get 3x minus 3. And then here, this cancels and this cancels, and leaves me with 1. So I'm going to have a little plus 1 on the end. Okay? And this simplifies it down to just a nice linear equation that is easier to solve. So the first thing I'm going to do is put the minus 3 and the plus 1 together. So 3x minus 2 goes over here. 4x minus 4 goes over here. And so what I like to do next is tackle the x's. I like having all my x's on the same side. I've got 4x here and 3x here, so I'm going to subtract a 3x. And so we'll get 1x minus 4 equals negative 2. And then we just add 4. And we'll get x equals 2. Now, something that'll be a little bit more important for this. Oh, you can't see what I'm writing. There it is. X equals 2. Something that'll be a little bit more important for this part is to make sure that this 2 is not going to make any of my denominators 0. So if I put it here, it's just 2. There it's 2. Here I'd have 2 times 2 minus 1. 2 minus 1 is 1, so we're good. If this happened to be one of the numbers that would make either parts 0, I would have to throw it out and say, okay, there's no solutions. Occasionally that happens. But this one's okay. It came out 2. Okay? So let's go over to number 6. All right, so the first thing I'm going to do is factor this denominator right here. So I'm going to go ahead and write r plus 5 on the top. And this is just a nice one that has the 3 terms that we can factor using the x. It multiplies to make 2, adds to make 3. So 2 and 1 would be my numbers. So I'm going to get r plus 2 and r plus 1 there. And then the rest of this is not going to change because it doesn't factor. These are already linear. There's no powers. There's nothing to factor. It's all good. So if I look, the things that I need to get rid of in the denominators is r plus 2, r plus 1, and this has an r plus 1 and an r plus 2. So that kind of lets us know I need to use both of those to cancel out the denominator. So just to make this neat, I'm going to rewrite it. Just take me a second. I'm fast. Maybe not that fast, but I'm kind of fast. And I'm going to multiply the whole thing through by r plus 2 and r plus 1 over 1. I'm kind of running into my number 5 problem, so I'm going to draw a line and make sure that that's not running it. So when we do that, we're going to keep things separate at first. So the top of this one is going to have r plus 2, r plus 1, and I'm just going to put parentheses around r plus 5 to keep it separate. The denominator is going to be r plus 2 and r plus 1. And if you wanted to go ahead and cancel these, you could, the r plus 2 and the r plus 1. You could go ahead and cross those off if you want to, or you can do it at the next step. It doesn't matter. And then I have my plus sign. I'm going to distribute this now to this next fraction. So I'm going to have r plus 2, r plus 1 over r plus 1. And so the r plus 1s, you can cancel now or later, either way. And then I distribute it over here to the other side of the equation, r plus 2, r plus 1 over r plus 2. And those will cancel. The main thing you'll know you did it right is if all the denominators are gone and it looks like we've canceled them all. And then we look at what we have left. So I have r plus 5 left over here, plus r plus 2 equals r plus 1. That definitely looks simpler than what we started with all those giant fractions. So now let's combine like terms. So the r's can go together, make 2r. The 5 and 2 go together to make 7. And on this side we have r plus 1. Scoot this up so I don't go off the screen. So we've got 2r on this side, r on this side. We're going to subtract an r. We'll get r plus 7 equals 1. Subtract 7. We'll get r equals negative 6. And then we want to check and just make sure, would negative 6 do anything to our denominators that's bad? Would it make r plus 1 equals 0? No. R plus 2 equals 0? No. Same thing here. So we're good. I think on my examples, I had everything working. I just want you to know, if this made a denominator 0, it would be bad and we would have to throw it out. Okay, so let's look at 7 and 8. For some reason, I have less room for 7 and 8 than I did for 5 and 6, so I'm going to have to be careful about how I use my space. What if I have something that's not a fraction? How can I make something that's not a fraction into a fraction? Over 1. So I'm going to make this n over 1 plus 2 over 1 plus 1 over n equals 1 over 4n. So there's nothing to factor in the denominators this time. They're all monomials. And so we'll get a little bit of a taste of what we did yesterday. So if I want to cancel out n and 4n, what would I multiply everything by?
4n.
4n. So I'm going to take it times 4n over 1. I didn't have room over here, so I'm going to write it on this side. And then I have to take and distribute it to all the pieces. So I'm going to have 4n over 1 times n over 1. You can go ahead and multiply that if you want, because nothing's going to cancel. So it'd be 4n squared. And actually, yeah, over 1 is fine. And then I will take it and multiply it by 2 over 1. So I'll have plus 8n over 1. And then I'll take it times 1 over n. We'll end up with 4n over n. And that's going to make the n's cancel. It gets rid of that denominator. And then when I take it times this part, I'm going to get 4n over 4n. And everything cancels. So what do I write when everything cancels? 1. So if I go back over here, these denominators are really going to go away. They're just 1. So I'm going to have 4n squared plus 8n plus 4 equals 1. This is a little tougher because it's going to be a quadratic equation to solve. So when we're solving quadratics, and we've got like that squared n and the regular n, we want to do something special before we try to solve it. Make it equal 0. So I'm going to subtract 1 here and here, minus 1, minus 1. And so I get equals 0 over here. This will be 3. Have 8 in there. 4n squared over there. Okay, so we have a couple of choices on how to solve this. We can do quadratic formula. We can try to factor it. We could slide, divide, bottoms up. What do you guys want to do? Which do you like? Quadratic formula?
Slide.
You like to slide, divide? Okay, so I'm going to slide the 4 down here, take it times the 3. So I'm going to have n squared plus 8n plus 12 equals 0. And then off to the side here where I have a little room, I'll make my x. I'll do it a little closer to what I'm actually doing, because then if somebody's reading the notes.
It's just 6.
So 12 and 8, yeah, it'll just be 6 and 2. So I'll have n plus 6, n plus 2. The part people forget is the divide. So when I slid and multiplied by 4 here, now I have to divide by 4 here and reduce the fractions. So I'm going to have n plus 3 over 2 and n plus 1/2 equals 0. And if I was just factoring, I could bottoms up, but a lot of people have figured out you could just use this equation to get the solutions. And so my solutions, if I make this equal 0, is going to be negative 3/2, and this one's going to be negative 1/2. And then we just check to make sure that's not going to make the n or the 4n in our denominators equal 0. No, because they're not 0, so we're good. So if you're factoring all the way, you have to bottoms up and then solve the equation. But if you're just solving, you could actually stop here, use the opposites, and you're done. Woohoo!
They're very involved.
They are very involved. Senior math is more involved. But you'll be happy if you're going to take college algebra to have this notebook. There's a lot of stuff in here that we're going in great detail and spending a lot of time with. That in college algebra, they're going to squeeze all of the algebra you've ever seen, plus a little bit more, into one semester, and it goes incredibly fast. And so I'm kind of going through this a little bit at a time, breaking it into more than one day, so we really have it down, and hopefully it'll just be a nice review when you take college algebra. I hope. They will throw some new stuff at you usually, but most of it's stuff you have seen before. In fact, I tested out of college algebra, and you can too. A lot of schools, you can go in and actually test out of it, and you still pay the money, but you don't actually have to take the class. Which is kind of cool.
Why would you pay for it?
Because you don't get the credit on your transcript, which goes towards your diploma from college. So, yeah. Unless, if you need to take other math classes, like I tested out of college algebra, but then I was going to take other math classes anyway. Duh, I'm a math teacher. So I went into calc, and that counted as my first year math credit for my gen ed requirements. And then I went on to take 30 more credits of math because I became a math teacher. So, anyway, let's go on and do number 8 and finish this up. So I do have a 1 over here that's kind of lonely. 1 is the loneliest. Okay, so we're going to put that over 1 just to make it a fraction so it looks like the others. It won't be so lonely. All right. So I'm going to have 1 over 1 minus 1 over n. That's already a fraction. And then I am not going to factor the numerator. That's okay to leave. But I am going to factor the denominator because I need to know what I need to get rid of the denominators. We're going to get rid of the... So this would factor into n and n plus 5. And it can be any kind of factoring down there, but you want to factor all the denominators, and then that'll help us determine what we're going to multiply by to get rid of the denominator. So what do I need to multiply by to get rid of all of the denominators? N and n plus 5, because that'll get rid of everything that I've got going on. And then this is over 1. And then I'm just going to take it times everything. So if I take that times 1 over 1, it's not very exciting. I'm just going to get n and n plus 5 over 1. And then minus, I'm going to take it times the 1 over n. So I get n plus 5 over n. If you want to cancel the n's right there, you can. And then on the next part, I'm going to have n plus 5, and then that n squared minus 6n plus 9, and then over n plus 5. Do you see why I didn't bother factoring that? Because this is all going to cancel, and that's what's going to be left. So we're going to have n and n plus 5. I do want to multiply that now. So n times n is n squared. N times 5 is 5n. And then here's the really tricky thing. I will tell you, this is the biggest mistake I've ever seen in teaching this concept ever. Do you see this minus sign right here? It distributes to the n and to the 5. So when I write it down, I'm going to have minus n and minus 5. That is the trickiest thing about the whole thing, I think. If you've got factoring down, then this is the only thing that might mess you up. If there's a minus, you got to distribute it. And then on this side, I already have n squared minus 6n plus 9. It's still a little messy. We're going to have to clean it up, but it won't be too bad to solve. So I'm going to put the 5n and the minus n together over here. So n squared plus 4n minus 5 equals n squared minus 6n plus 9. And so since I do have some quadratics and stuff there, I want to try to get things simplified a little bit. If I take off an n squared, this gets a little bit easier because those are just going to go away on both sides. And I'm going to have 4n minus 5 equals negative 6n plus 9. It's not actually a quadratic. It's just a regular equation, a linear equation that we can solve. So add 6n, add 6n, 10n minus 5 equals 9. Add 5, I'm running out of room. 10n equals 14. Divide by 10, divide by 10. So my answer is 14/10, but I want to reduce that, so I'm going to make it 7/5. Generally speaking, unless this happened to be attached to a story problem, they're going to give you a reduced fraction. If you have a choice between improper or mixed, they're usually going to leave it improper. I will tell you everything on my answer keys is just left improper fractions.
That's the homework.